All right, number 3, we've got a f prime graph, but our questions are about f. Good thing to remember in a scenario like this is that if I integrate the derivative of f, I get the change in f. That's our fundamental theorem of calculus. So in this case, I have a -2 value known and a -6 value unknown. So -6 to -2 integral is going to be the value at f of -2 minus the value at f of -6. If I can know 2 out of 3 of these, I'll be able to figure out the third. So f of 2 is 7. F of -2 is 7. F of -6 is what I'm looking for. And the integral from -6 to 2 of f prime is this triangle right here. So that's 1/2 4 times 2. So what I end up with is 4 equals 7 minus f of -6. And f of -6 is going to be 7 minus 4, which is 3. In a similar way, I'm going to look at the integral from -2 to 5 of f prime being f of 5 minus f of -2. All right, the integral from -2 to 5 is going to be this semicircle, which is going to be a -1/2 pi r squared. And I'm going to go all the way to 5, so I also have to add the triangle, which is 1/2 of 3, base 3, and height 2. That integral is going to be equal to f of 5, which is what I'm looking for, minus f of 2, which is 7. So f of 5 is going to be equal to 7 minus, this ends up being 2 pi, and this ends up being 3. So I end up with 10 minus 2 pi. All right, for letter B, on what interval is f increasing? All right, f is increasing when the derivative of f is positive. So all I have to do is identify the intervals when the derivative is above the x-axis. I've got -6 to -2, and I have 2 to 5. Be sure to have some kind of a sentence or a statement justifying your reason there. All right, C says, what's the absolute minimum value on the closed interval from -6 to 5? So over this entire interval, what's the absolute minimum? So we want to start off by thinking about our candidates. Our candidates are going to be the endpoints. So I've got -6 and 5, and also any critical numbers, so places where the derivative equals 0, I've got -2 and 2. And our best course of action is really just to figure out every single value of f for those. The good news is we've done a couple of those already, and let's think about that. We found f of -6 in part A, that was 3. We found f of 5 in part A as well, and that was 10 minus 2 pi. F of -2 is given as 7. And then the only thing that's left for us to find is the integral from, or f of 2. And f of 2 is going to be f of -2 plus the change in f prime. And that f of -2 is 7. The change is going to be the semicircle there, which we already figured out was minus 2 pi. And so that's what f of 2 is. It's the 7, the value of 7 minus 2 pi, so 7 minus 2 pi. I'm looking for the absolute minimum, so looking through these numbers, I want to think about the smallest. So 3 is small, but 10 minus 2 pi, actually that's going to be, 7 minus 2 pi. 2 pi is going to be about 6.2, and this one's going to be a little bit smaller than all the rest. All right, last part, D. it asks us to think about f double prime of -5. So that's simply the slope of the graph at -5. Right there on my graph, I need to think about this line segment. I'm going down 2/4, so that's going to be -2/4 or -1/2. And f double prime of 3 is going to be the slope of the f prime graph at 3. Since there's a corner point there, that does not exist. You can say corner point, but a little bit better explanation is to use limits. So the limit of as x approaches 3 from the left of f prime does not equal the limit as x approaches 3 from the right of f prime. And that's a good way to emphasize that f double prime of 3 does not exist.